Assalamualaikum and good afternoon everyone. We are gathered here today because our team would like to describe the status of production of the LajakLaku tablet G in December 2020. Our presentation is distributed into three parts which includes a summary of data of the shift, weight, relative density and tensile strength of the tablet, a commentary on the normal distribution, a significant difference between tablet weights from a different shift, and a prediction of the tensile strength of the tablets at the given relative density. I would like to introduce our team. Alan Wong Zong Xiang, our Operation Planning Manager, I, FAKHRUL TARMIZI, the Quality Control Manager, IMRAN SHAHRIAR, the Production Manager, and Muhammad FATWA RIFAI, the Distribution Manager. Without further ado, let's begin our analysis. First, we will start with a summary of the LajakLaku Tablet G production in the December 2020. As you can see here, we sort our data into three shifts: morning, day, and night. Frequency means the number of tablets occurring in each shift. So, frequency of 77 occurs during the evening, which means that 77 tablets are produced in the evening. As total tablets produced is 200. This means that 77 out of 200 or 39% of tablets are made in the evening. Evening shift has the greatest number of shifts, which is 77, while the night shift has the lessest number of shifts, which is 56. The total number of tablets in all shifts in December 2020 is 200. You may have a further look about the details to other shifts as shown in the P chart. Then, I invite Imran to explain more about the data of the production of tablets products in December 2020.
Okay, hi. So here we have summarized the data which tells us the sum of the weights of the tablets in a shift, and thus the average weight, the standard deviation, and the variance of weight of tablets in each and all shifts. So from the table we can see that the average weight of all tablets in December 2020 is 349 milligrams. So we sorted the data of the weight of all tablets into different tables, and then we plotted a histogram so you can see it's shaped like a bell. This is normal distribution. So the highest value 54 means that 54 out of 200 tablets have a weight between 350 and 360 milligrams. So weight is most likely to fall in this range. Conversely, 3 out of 200 tablets have the least probability, which is above 380. So it's least likely to be in this range. So here we have a table showing other important data of the tablets, such as mean weight, which is the average weight, median weight, which is the middle value of the weight, the range, which is the difference between highest and lowest value, the mode, which is the most common value, the standard deviation, which is how much the weight can vary from the mean, the sample variance, the minimum and maximum weight, and the total sum of weight for all tablets and the number of tablets. So just like we did with the weight, we do the same process for relative density. So you can see here we have all the data just as before: sum, average, standard deviation, and variance, and for each and all shifts. So the total relative density of tablets in 2020 is 17605.9%. So just like before, we plot a histogram, and we can see here that most of the tablets will fall in between 87 to 89 because it shows the highest percentage, which is 34 out of 200 tablets, and the lowest is 2 out of 200 tablets, which is below 84%. And here we have the data summarized for relative density of the tablets produced in December 2020. Again, we do the same process for tensile strength. So as you can see here, we have the sum, average, standard deviation, and variance of tensile strength for each and all shifts. And from the table, we can see that the total tensile strength is 1428.9 MPa, and the average is 7.14 megapascals. So again, we plot another histogram for tensile strength. So you can see here that the range between 7.2 to 7.3 has the highest frequency, which is 42 out of 200, while the range that is below 6.8 has the lowest because it is 2 out of 300. So the mean tensile strength is likely to be below 6.8 megapascals. And here we have the extra data of the tablets produced in December 2020.
Hello, I'm Fatwa. Since there are requirements from Food and Drug Administration, I will comment on the normal distribution of the weight of tablets, whether it is normally distributed, with mean of 350 milligrams and standard deviation of 14 milligrams. We first developed a null hypothesis, which states the weight of the standard tablets produced by the manufacturers are normally distributed with 350 milligrams and standard deviation of 14 milligrams. Alternatively, we make an alternative hypothesis which claims the weight of the standard tablets produced by the manufacturers are not normally distributed with 350 mg and also the standard deviation of 14 mg. We perform this test with a significance level of 5%. We organize the data into 6 groups in a normally distributed manner and perform a chi-square test. The sum of these values is 3.5071. Since our calculated chi-square value is 3.5071, which is less than the chi-square at 5% significant level, 11.0705, so we fail to reject the null hypothesis. We can conclude that the standard weight of the tablets are normally distributed with 350 mg and a standard deviation of 14 mg. To ensure that the weight of the tablets will remain steady regardless the shift is made in, we will determine whether there is any significant difference between the tablets' weights in milligrams from the different shifts. So like before, we have to set up a null hypothesis where all the means are equal such there is no significant difference between the tablet weight from the different shifts as requested. As an alternative, we can say that at least one of the means will not be equal to each other, which means that a significant difference exists among different shifts. We perform this test using a 5% significance level. For this, we'll use the one-way analysis of variance, known as the ANOVA. Here we take the production data and organize them into the columns based on their shifts. We run the ANOVA using Excel. From the result, the p-value here is 0.9475, is more than the significant level of 5%, so we do not reject the null hypothesis. The concludes here, there is no significant difference in mean of weight the tablets amongst the different shifts.
Since a batch was found to produce a cluster of tablets that show low reactive density, next we will predict the tensile strength for such tablets with reactive density values of 68%, 74.3%, and 80.1% based on the current data in December 2020. A simple linear regression model is used to carry out the prediction. Based on the regression analysis summary output from Excel, the result shows that the trend line of the graph has steepness 0.0792 and y-intercept 0.1729. Based on the analysis, we plot reactive density line fit graph. By this, you can see the trend between the reactive density and the tensile strength. Using the graph or the equation stated before, we can predict the tensile strength at any reactive density of the tablets in December 2020. In short, at 68% reactive density, we get 5.56 megapascal tensile strength. At 74.3% reactive density, we get 6.06 megapascal tensile strength. And at 80.1 reactive density, we get 6.52 megapascal tensile strength. Now we will validate our model that we use to carry out the prediction by assuming our null hypothesis be the slope beta 1 of the graph is 0, while the alternative hypothesis suggests otherwise. The hypothesis test is carried out at 5% significance level. We carry out regression analysis and ANOVA. From our result, the Pearson coefficient is 0.8573 and the graph is confirmed to have positive slope, while the F value of our regression is almost 0, which is less than our significance level 5%. Thus, we reject our null hypothesis, which means that the slope of the graph is not 0. From the two confirmation tests, we can conclude that there is enough evidence that the relationship between the reactive density and the tensile strength provide a strong positive correlation on the existence of linearity in LajakLaku tablet J at 5% significance level. And finally, that shows the conclusion for our presentation. Thank you for taking the time to hear the explanation of our report. We hope it fits the best interest of the LajakLaku company.